Hi, everyone. Welcome to our panel discussion today, how eBPF is changing application security. My name's Katie Norton, and I'm going to be moderating today's conversation. I'm an industry analyst at IDC, where I lead our DevSecOps, application security, and software supply chain security research practice. I am thrilled to be joined by a really incredible panel of experts who bring really deep technical expertise and practical experience to the table. With me, I have Brian Joe. He is the co-founder and chief product officer of Impart Security, a WAF and API security provider. We also have Francesco Cipollone, co-founder and CISO at Phoenix Security, a contextual, actionable ASPM that defines the remediation paths for application security engineers. And then finally, I have Daniel Pacak, a software consultant passionate about securing modern cloud-native applications by harnessing eBPF and other relevant technologies. So we're here to explore a topic that is really hot and reshaping how we approach modern application security, eBPF. eBPF unlocks a really wide range of possibilities for observability, networking, and most importantly for our discussion today, security. eBPF is growing in hype, and it's as an increasingly standardized way to observe application and cloud behavior and really improve security posture. But with so much hype, we need to separate what's reality from what is the true future promise of this technology. So I think in this discussion today, we're going to unpack this and the reality of eBPF, where we are right now and where we're going. So let's kick it off with maybe an obvious question. Daniel, can you answer for me, what is eBPF and how and why are so many people in security interested in it?
Yeah, obviously, I think this will help us framing the discussion. It's currently, the acronym itself, I think, is a little bit meaningless. It was in the very beginning when so-called classical BPF was used for capturing network traffic. And therefore, it required quite significant development in the Linux operating system kernel itself. But you might imagine that this development, like capturing network traffic, is pretty complex, but also must be efficient because our computers, our servers in the data centers process lots of packets, lots of data. So this was pretty innovative at the time. Again, I'm not going to go into too much details, but just to give you roughly the idea. And it was so cool because most people were not interested in all the traffic. They wanted to focus on a certain IP or a certain port. So they needed efficient filtering and a secure way to dump the data from the network interfaces to the user space for analysis. And that was like a great success, but then it opened a lot of other opportunities because the infrastructure, the subsystem in the kernel was there. And why not tracing for example, syscalls, right? Just for you to know, like most of the applications that we care to secure operate in so-called user space, userland. And when they open a file or connect to the internet, they ask a kernel operating system to do those operations. So then again, it's a great opportunity to hook into a certain place in the kernel and observe not only the network traffic, but now how the app interacts with the system. So we can now imagine that this opens a lot of opportunities to develop applications that trace activity. Now, once we collect all this data, I think we'll be discussing today how to leverage this data. And maybe one important technical note is that previously it was possible, but required like a more development and involvement in the kernel itself. So eBPF is, let's say, linear way to load those modules. However, it's not also solving all the problems. And again, I think we'll deep dive into the details.
Brian and Joe, do you have any thoughts on how, as providing security products yourselves, how you felt eBPF has impacted?
Yeah, thanks, Katie. And Daniel, thanks for the explanation. I found that super accessible. Yeah, it's hard to find a security startup these days that isn't talking about eBPF, in my opinion. I think, as Daniel said, it does unlock visibility in a way that just was a lot more involved before. So I think that is really interesting. I think what has been hard sometimes though is I do feel like the messaging or just the explanations of what eBPF is used for and what it can actually do, sometimes it gets a little blurred. I think for security teams, a lot of the time, visibility isn't just the end all be all. There's eBPF is this really interesting technology, but what are the most relevant use cases that someone can use it for? Or what problems can they solve is sometimes we ask ourselves a lot. But it certainly does level the playing field in terms of how can new companies get access to data that or customer data or internal cloud data that previously would require a longer instrumentation process. I guess, Daniel, from a technical standpoint, would you say how far along the maturity curve would you say eBPF is? Would you say it's a pretty mature technology at this point that is here to stay? Or do you still think that there's a lot of room to grow in terms of making it more production ready, more broadly adopted?
That's a great question. And yeah, I wanted to start without going into the details, but at some point when we talk about deployment and installations, that's something to consider. And this is constantly evolving system. As I said, from the packet tracing now to observing nearly any aspect of the running system or a running server, you can write many different types of programs and you can collect lots of data. And this data has to be processed somehow. The eBPF VM, like a virtual machine running in the kernel, it's sandboxed. So you can't theoretically break the system with your eBPF programs. They are isolated from the core components, but many things are missing. For example, there's a big limit on the number of instructions. So like a complexity of the program that you normally would like to place, right? It's not like a Java application when the user space or a memory of the server is a limit. In kernel, there's a number of instructions. So you have to be really careful what you really want to run in the kernel. The other pain point is the support of different versions of the kernel. As I mentioned, this is a constantly developed subsystem, constantly evolving. As adopters are requesting new features, those are only added to the latest and greatest Linux kernel versions. However, not all of them are backported. And as most of the production-ready systems are not like readily upgraded overnight, right? It's a process. It requires like a testing, especially for the legacy applications. This might be a challenge. So there is this kind of, I won't say hidden, but not maybe things that you pay attention immediately, but very important to consider before you go for the eBPF-based solution. The last but not least, from my experience, is the very steep learning curve, right? The eBPF is easy, but when we run a demo like a Hello World application, we can't compare it to the real agent, which is powered by eBPF technology. There's tons of data to be ingested, to be processed. So we either have a very intelligent data collection, efficient, so we don't overload a real application workloads with our security and solution. On the other hand, if we decide to collect lots of data, it becomes a data processing problem. So real online analytical processing platform. So I think those like the most, I would say, important things to consider as well when we talk about eBPF.
Those are some great insights. And I think it helps maybe transition us to the next topic that I want to kick over to Francesco is on what's the real world impact of eBPF. We talked a little bit about some of the challenges, but what has eBPF unlocked for Appsec today?
Thank you so much, Katie, and thank you for the effort of the name. I think to connect back to what Brian was saying, there is a lot of hype on eBPF, and as blockchain and as AI is not the solution, but is a path to a solution. That is the observability problem with container, with more code running in a layered way into the cloud, and with team having less knowledge and visibility, because right now every team is an Appsec team, but not every team member comes from Appsec. Some of them come from GRC, some of them come from SOC, operation, traditional patching. There is a very steep learning curve of how do we remediate a particular vulnerability in a particular container, or what do we do with this information? So I think what Daniel was mentioning, first of all, are some of the challenges that came with traditional RASP or traditional agent-based installation. Now eBPF might level the playing field, because as time comes, all of the build that in container and in base image will be equipped with the latest, the greatest, or at least a version from eBPF. But I think right now, eBPF is a technology that gives us observability of what runs inside a particular VM, or what network profile are there, or an easier way to inject code inside kernel. So basically doing application level firewalling. So there is tons of application, but with great power comes great responsibility. There is also code that runs in a kernel. From a banking perspective, where us and Phoenix came about, there was always the challenge of trusting an agent that was running inside memory in the maximum level of privilege that run command from a third-party system, because we've seen a lot of the open source vulnerabilities, XZ and so on, that fundamentally corrupted open source packages. And with that, there is always the fear, hey, my application runs in the most protected level of an operating system that maybe has access to memory that is unencrypted. So for any payment gateway, for any transaction gateway, for anything that process really critical information in memory, loading third-party code in memory is sometimes terrifying, especially on a technology that is early. But on the opposite side, it provides almost an API query with all the challenge that Daniel was mentioning of data load and the complexity of actually dealing with the entirety of the kernel stack and the rawness of this data and translating that into the security use case. But just a long-winded answer to, hey, eBPF is a technology to observe more container, but reachability is really what we're looking for, and blocking stuff inside the kernel. Those are really the solution that we're looking for to fundamentally reduce the number of vulnerability that we really need to look at, reduce the overload in terms of development, and really see which network device or which container is actually more externally facing, or where we can block potentially vulnerability at kernel level. But it's not the only solution in there. We have tons of other observability tool and technology and raw API data. The power of eBPF is that probably in the future will be in every container. For now is in some of the Linux container and Linux kernel.
Yeah. I think it's so interesting that you mentioned reachability analysis as a way to whittle down the number of vulnerabilities that a security team has to deal with. I think that speaks to a larger problem of just how many vulnerabilities there are that a given business or enterprise is actually actively dealing with. I spoke with a customer in the banking industry about 2 months ago, and she was telling me that her organization literally had over 1 million vulnerabilities just in their cloud from one scanner. Do you say 40 million?
Yeah, for what we observe, 40 million with at least a couple of million just on the critical side is fairly the normal. We start with some of our clients, and not even the large client, SME. And this to speak to the volume and to the scale that not just image, source image or image in the registry, but also the running container and the wave and scale of this container can bring. But 30 million is for an SME of 2,000 devs.
And I see the same thing in the end users I interact with. I think this touches on, and maybe both you all can speak to this, is how then is eBPF digging into how is eBPF helping deal with this issue, right?
I think if I can jump in here, because I've been punching eBPF for trying to solve this problem, and I think it's a stage problem. Like reachability analysis operate at different stage. You have a static code reachability analysis that remove a chunk of vulnerability or a chunk of library that are not even loaded into the container. So instead of adding the level of complexity that is required to actually monitor an application as a black box that gets loaded in memory and then reconstruct that, there is a much easier way to actually address those vulnerabilities when the package gets built in itself. And it takes a fraction of, depending on the complexity of the application and the language, it might take minutes but not the hours that takes fundamentally to analyze a container running in memory. Now, there is a second part that we use different scanner. We use open source scanners at source code level, and then we use container scanner that are completely separated. So there is duplication of triplication of vulnerability being sent to the various scanners. And with the good and the bad, the DevSecOps methodology have brought in, there was a shift left approach that have been bastardized, unfortunately, into, hey, the scanner says no, hence you block the build. The problem is those scanners have a point-in-time view of the world, and hence the number of noisy vulnerability get frustration in development community, because if you block a build when you build a container, and the software that is in there is actually the one that causes issue, you will cause an enormous frustration in development because the issue is not in the container, is in the source code. So the traceability and the reachability analysis that a piece of code that runs in a container can be solved with eBPF, can be aided by the eBPF, but it can't be solved by eBPF. So I think where eBPF really helps is understanding if a particular module is loaded in memory, and you have certain solution in the cloud that says, hey, this particular library is actually reachable. Now, I will argue that anybody that jump on a box and compromise a box will load any possible library memory that has access to, because we get blindsided by this prioritization method. And I talk against my solution because we are doing prioritization, but it's a battle between identifying what are the more burning issue. In 30 million vulnerability, you probably can touch 10 per sprint per team. So you need to consistently burn down the access part that usually is remote code execution or memory corruption vulnerabilities. So if you focus on those, usually those are the one more urgent to tackle. And analyze reachability analysis is one of the things that we do in Phoenix, but at different stage. We have 4 different levels of reachability analysis. Sorry.
I think what's most interesting about this panel is you've all worked with a variety of different Appsec technologies. Is there other ways in which that you're seeing the benefits of eBPF as it relates to Appsec in the work that you're doing?
I can add to that. I think Francesco is spot on from the product level. Indeed, like what is reachability, or what is the goal of the security project? Is it a stopping zero-day attacks? Is it vulnerability management? This should be like a question number 1, because there's no one product, one project, not a one eBPF program that will solve all of them. You need a bunch of maybe agent or agentless solutions integrated. Maybe you just need open telemetry, manual or automated instrumentation. I think looking at those different tools and products, and that's like my daily job, trying to think out of the box. I think we are at the stage where many vendors tried eBPF. They like it or hate it. Some of them were more and less successful, but there's still plenty of opportunities. We see also a little bit of a copycat trying to just say or check mark in the list in their product, where basically they say, yeah, we do provide reachability analysis, but it's far from being complete. Maybe there are better ways that they could easily or not so easy get to. And one more thing for me is that so far the existing projects, and without names, look at the perimeter. They use eBPF to look at the perimeter of the application. And exactly to Francesco said, this is not enough. This does not solve this kind of a vulnerability management problem. This will not tell a developer, look, in this application, in this line of code, you introduced 10 vulnerabilities, right? It will not help you getting rid of dormant vulnerabilities that are never executed, right? It's just a security hygiene. When everyone tells you, use the smallest possible image. I'm a developer. Lots of developers hearing us will say, yeah, I don't have time. I need to push features to production. So it's important, but it's not, in reality, it's very hard to achieve. Like everyone tells you, go to the gym. It's easy, but how many of us go there, right?
I actually had a solution to that. A couple of my clients brought me forward to use. We charge as Phoenix for vulnerable machines or vulnerable assets, or charge a fraction for non-vulnerable assets. So some of our clients from the CISO community start talking with the CTO to actually archive library archive projects, reduce the number of images in a registry. So start using security observability to actually start reducing the technical debt that those technology debt that traditionally is, we have infinite space in the cloud, in a registry, in GitHub, will bring into more effort and overload or cognitive overload or security overload, and hence security costs. So we actually help our client actually reduce our bill and everybody else's bill. So we're not probably the most loved vendors in the vendor community, but with one of the most loved vendor from the CFO and procurement.
I love the idea of reducing technical debt or reducing almost the vulnerabilities from legacy applications. And I think eBPF is interesting because at the same time that it is really pushing the envelope on what is possible easily, getting system-wide visibility, it is also not addressing the legacy problem at all, in the sense that we deal with a wide range of customers of different like maturity levels and ages and sizes. And most of the large enterprises we work with, all of their new stuff is very modern. It's all cloud native. It's in Kubernetes, right? Developers are very involved in the security process. And in terms of the additional visibility that eBPF provides, the development teams have built in a lot of that already using existing observability things like tracing or APM or those kind of things. But for the legacy applications, those are applications built 20 years ago. The team's no longer with the company, and but they're mission critical. That's why they're still around. And I just think it's interesting that eBPF doesn't help provide additional visibility into those applications. And so it's interesting to see the divergence of like innovation on the one hand for cloud native, really pushing the envelope of what's possible, but leaving behind like some of what may be mission critical older applications running on Windows or IIS or those kind of things.
My last survey had 18, my last Appsec survey had 18% said they were deploying an application to a mainframe. So
we actually did repurpose mainframe for private cloud, and we had very modern API in front of very legacy stored procedure in COBOL. The problem is those people are very rare to find, and doing security assessment or threat modeling on that scenario, but it is a nightmare.
Yeah. And it goes back even to the limits of visibility on those kind of applications, because for the most part, no one wants to touch a COBOL application anymore, right? You want to leave the code the way it is. If you find a vulnerability, you don't want to go in there and make a change. What you actually want to do is try to mitigate the impact of that vulnerability without touching the old code and risking something even worse. So I think that the idea of virtual patching or that has really, and obviously we're a WAF API security provider, but that's really been a core use case of ours. We run into teams where there's no findings from a pen test or any other kind of analysis, but the cost of making a change is just too difficult, whether it's because there's too many other vulnerabilities on the backlog or because the cost of making software changes on older applications is so high. And so I think the way you framed it, Daniel, what problems are you solving? Like 0-day problems. I think eBPF is actually pretty well suited for that, but maybe things like general web attacks, business logic abuse, though there may be more limits around that from technologies like eBPF.
Yeah, and also to add to what was mentioned is, and since it's a panel about eBPF, there is actually an initiative to standardize the bytecode. Now, this part can be generalized to Windows machines, but it's, as we also said today, it's a constantly evolving and extended subsystem. So one day we will cover Windows servers, hopefully with eBPF, but right now it's not, it's a POC kind of stage. Circling back to the point of open mind approach and what Francesco said about observability, and I think Brian also mentioned this, I believe in a hybrid approach, right? Maybe you should not target every Kubernetes pod or every workload with a very powerful and expensive, at the end of the day, eBPF agent. Maybe just target it at a critical application or a critical node or a critical cluster. For the rest, use more, I would call, lightweight solutions. So I think any vendor who is thinking out of the box and will use static scanners, binary analysis, and maybe in some places eBPF, and then collect all the data and combine them in a meaningful outcome or actionable alert, will be the winner. But we have to work on that, and I think this is like lots of and plenty of opportunities for engineers, startups, and everyone out there. I think it's really exciting place.
I love that you bring up the idea of cost. We run into this a lot with some of our high volume customers where, or even prospects, when we go to talk to them, one of the ways we deploy, for example, is with an agent. And when people hear agent, they think, oh, you got to have this agent running on every single machine in my cloud. That's millions of dollars just for security. And for anyone dealing with any real amount of scale, that actually just becomes a non-starter, right? The cost, scale up events, live events in particular, if the cost of a security tool is, call it 10% on top of everything you're already running, that's going to be a non-starter. So for us, when we solve WAF related problems, for example, we'll instrument an agent just at the egress location, right? We won't go all the way back to the API tier or the web application tier. And that actually gives us a nice efficient fan out point from which we can, because as you mentioned earlier, Daniel, there's a ton of data that needs to be analyzed. We're looking at network data. It's pretty much the heaviest data you can be carrying, right? It's just a constant fire hose of repeated information. The performance trade-off of using technology like eBPF, like listening to all the syscalls on every host, really introduces a data engineering problem. And I think that's the part that also gets left out of a lot of the hype, right? We can get visibility really deeply on one machine, but what if you have a million machines? How are you passing around all the data? What are you looking at? You have to get really smart about what you're looking for, how you're looking for it, how you're analyzing it, where you're analyzing it.
And also, I think we have a great opportunity to maybe clarify the marketing part of eBPF, that everyone says it's efficient. It might be efficient if it's used efficiently, because part of the challenge is this code is running in the kernel, right? It's sandbox, but it's running in the kernel. And as you, Brian, said, if we attach a BPF program to a syscall that's very often called like opened event, right? For example, when the file is opened, everything in Linux is like a file. If not file, it's a process. So we can get all of these events. Now, the other problem is that eBPF doesn't know anything about Kubernetes, containers, clouds. It's really low level. It's a different abstraction. It's a completely different world. So this raw event coming from the kernel has to be enhanced or merged with the metadata. Which pod is it, right? You want to present this data with meaningful context. So you are like trying to do a very fast stream processing where kernel is the fastest one. You can't catch up. So you have to do smart data processing pipelines asynchronously and then do online analytical processing. Or, as I said it before, focus on innovation in eBPF. Don't do copycatting from others because they are typically just generate events. Do smart data collection. Just giving some insights. I don't know personally how to do all that stuff, but this is a real challenge.
Yep.
Yeah. All right, I'm going to pivot us a little bit to maybe a spicy question. Not that we've had some pretty spirited debate so far. Is eBPF security technology or an observability technology? Brian, you want to take a stab at that first?
I'll take a stab at this one at the risk of causing a hot take. So let's maybe start with defining what is security and what is observability, right? So the way I look at security is the act of or function of reducing risk, right? And I look at observability as just a way to get visibility, right? Better visibility, better understanding of what's happening. And I think my hypothesis, or what I'd argue, is that we are living today, security today, the security industry today is drowning in visibility. There is way too much. I think, Francesco, you even threw out some numbers earlier that were larger than the ones I've heard, like 40 million vulnerabilities for an average size SMB or enterprise.
13.
Oh, 13. Okay.
Yes.
Okay. 13. Okay. Still daunting and probably too many. But what I would say is, security teams don't need more visibility. They already have 13 million vulnerabilities that they've been told about. So then that just means, okay, it's from a security standpoint, how do you actually reduce risk given that environment? And I think we just can fall back to the way that application security has always worked in terms of risk reduction, which is you can reduce risk two ways. One is you can remediate vulnerabilities by working with developers and engineers and improving vulnerability, remediating code vulnerabilities. And the other is you can stop attackers. And that is where technologies like Impart, where you can actually block attacks with a WAF-like approach or an API security approach. That is the other way to do it. And I think what I'd argue is eBPF maybe can help you figure out which vulnerabilities are most important, but it's not going to fix them for you, right? Like you still need to go to an engineer. And similarly for a WAF blocking rule, eBPF isn't going to be able to block like a WAF. I think, Daniel, you mentioned it earlier, like eBPF is just operating at a different abstraction layer. It has no idea of Kubernetes and containers, as you mentioned, or even like layer 7 packets, which are really critical for blocking things and blocking attacks in the application context without causing a whole bunch of network problems in terms of smooth error codes, HTTP response codes, and things like that. I think when we look at both of those traditional ways of improving security for enterprises, and we see that eBPF doesn't really help with blocking, and it doesn't really help with remediation, other than helping you slowly whittle down that large list. So I think what I'd argue is it's a great observability tool. It's certainly giving security teams and engineering teams more information and more visibility, but it isn't helping her to reduce the risk at all.
Anyone
Let
else?
the hot takes begin.
Sorry,
Go,
Francesco,
Daniel.
go ahead.
No,
So I
you
can
go
just quickly back up what Brian said. I'm a strong believer in how powerful this technology is, but we have to stop copying existing code, start doing things differently. We need smart data collection, right? We don't want to generate more data. We want to shrink the number of data, but give more context out of the kernel. Now there is a problem, the limit of instructions in a BPF. So I think it's not only developers, security vendors, or application developers. We need also kernel maintainers to implement all these feature requests. It's very hard to parse in the kernel packet, like a HTTP packet, not to say all this encryption, etc., right? In the user space, you can do that because you can have libraries for parsing HTTP, DNS, gRCP. You can do nearly everything. So I think also many vendors nowadays take code from observability tools like BPF Trace or existing tools that were meant and built for debugging applications, for observability. And there's one problem. Those tools were like supposed to run for a while and then be stopped. Like you can't constantly profile an app because it might negatively impact the performance of your application. There's an overhead of the security agent that we mentioned already. But on the other hand, there is also the, as I mentioned, complexity. It's very complex. And some of those solutions that I know are deployed in production are, first of all, require like elevated privileges. So they become like a vector attack on their own. But also if a eBPF program is written in a very naive way, it's also vulnerable to a time of check versus time of use attack, right? So they are pretty easily bypassed by, I'm talking about like a more advanced attackers, not like a scripting kiddies. So those are like also very important aspects. And I do think, yes, the eBPF is for observability, and we need to innovate in eBPF and in the data analytics. Those two things might bring very interesting results coming forward.
I would like to maybe take a take on that and throw a hot take on what Brian said. I think security people have too much visibility, but on the wrong visibility. Like they don't have visibility on the things that help them remediate. They have visibility on the noise and on the problem, but they don't have the visibility on the how. Which user is touching the codes? Where is the code coming from? How long has it been running? How exposed it is? So those are the data point that a security professional and a developer can use to then go to remediate. I think in security, we've been obsessed with attack path, but we left out that is sexy, don't get me wrong, but we left out the remediation that is boring, but is the one that's going to help us reducing. And it's a data analytic problem. Static reachability analysis, traceability analysis to know which code runs where is not super sexy, but it helps enormously with the remediation of vulnerabilities and pinpointing exactly where that vulnerability is. Probably something that can help you understanding how externally reachable is, or if something is loaded in memory, but that's it. It will not help you in any other part of the attack path vector, and it will generate an enormous amount of complexity on the user side, and you hit the agent problem. And on a vendor side, where you need to process this data properly, you're not going to be precise when you experiment. I would expect that any young startup will spam and will have an enormous data set on top of the enormous data set that is like this. But hey, VC love the latest keywords.
I think a lot of us have agreed on the benefits of eBPF and having more visibility, but also just the limits. And it's interesting to me that a lot of us have come back to the data engineering aspect of it, right? The data processing and transfer and knowing what to sample and look for at the time of collection. So I think there's a lot of practical realities that a lot of companies are looking at solving. But I do think there is a pretty large eBPF industrial complex where there's a huge incentive for folks who are really leaning into eBPF to really talk it up. And also a huge incentive to avoid talking about everything we've discussed today, which is all of the practical realities and really just the solid engineering that's really required to support an eBPF-based instrumentation path. I think it's great that we're able to talk about both and have a balanced take on both the promise, but also the reality, and not necessarily be a part of that complex.
Mm-hmm. I agree with you. I think this transitions well into sort of our last kind of big question here. And as an analyst, I talk to a ton of vendors, right, all across the Appsec landscape. And I love the eBPF industrial complex way of posing these things because I see it every day in my job. And one of the fun things that we get to do as analysts a lot of times is look into our crystal ball and tell what's the predictions for the future. We're known for that kind of stuff. So I'm interested from all of you. We've been talking about today's realities of eBPF, but what does the future look like from each of your perspectives as it relates to this tech?
I can start, maybe. So I believe many, as Francesco said, small startups and VCs that are not listening to us will break their neck by adopting eBPF technology, basically, or they run out of money because they will collect too many data that they cannot persist and analyze. On the other hand, I believe those who persist in enhancing the technology, get involved, will come up with a very interesting ideas. I don't want to mention the name, but there were like a very recent innovation in eBPF space. It's related to stack unwinding. So it's like a classical computer engineering problem. It's not marketing. We have to do a thorough computer science and understand it deep dive. As I like to say, you can't secure what you don't understand. So focus on use cases and focus on the technology, where it can break and where it brings value and how expensive is that in total. So I'm optimistic. That's my day job, but I'm also very aware of what we've talked about.
Francesco. Oh, okay. I'll go. Yeah. I don't know. I've dropped a few hot takes today around security. eBPF is not a security technology, and eBPF industrial complex is overhyping eBPF. I think those are pretty hot, but I'll try a third one. No, I think eBPF at the end of the day is an open source project, right? Highly coupled with Linux. And I think it will follow the path of most open source projects and Linux historically, which is everyone's going to have it, right? Everyone's going to have access to it. There's not really going to be any differentiation in the long run. Just like there's really no material differentiation between different versions of Linux, like Ubuntu versus any other version. For the most part, there's little small differences in terms of ergonomics, but functionality wise and application wise, they all do the same thing. They all support the same things. And that's a long run. I do think eBPF is just going to make it easier and easier for folks to access that fire hose of syscalls which include all sorts of rich data. I think that the value add in eBPF is really just going to be in the engineering side of it. Like almost like what you mentioned, Daniel, which is, do you know what you're looking for? Do you know what problem you're solving? And can you build a tool that is highly optimized to solve that problem? I do think general purpose approaches to like collecting all the information and then figuring out what problems you're going to solve later, that to me, it seems very reminiscent of just like another version of SIM. And I think what we've seen is like, there's the SIM industry right now is, or most SIMs are just full of noise. I think that is probably going to continue with eBPF if folks are taking a non-focused approach. But I think providers who are really narrowed in on a single problem or a small set of problems, like what you mentioned, Daniel, unwinding the stack traces, or for us, WAF, API security, I think that's actually going to let us build solutions that are more performant, deliver better results, and ultimately are more efficient for all of the data that's there. What's your hot take, Francesco?
My hot take is no client asks for reachability analysis or eBPF. And this is a little bit what we need to build to address the problem of the future, but we still left out with the problem of now. So I think those are all tools that we need to use to actually continuously burn down overloads of problems. And I think right now the main pain point is actually on container, how they're created, and the management and the sprawl of container that is in there, together with where open source library come from. That I think has been, with the hype of AI, has been a little bit forgotten, but is returning like super, super hot. So my hot take is fix a real problem that is suggesting the remediation, not the problem for vulnerability management. Forget all of this noisy data. It can help, but there are a lot of explored way, like Daniel was mentioning, that are probably easier or less computational intensive, maybe less exciting, because you can't mention the latest hot word that is AI, eBPF, reachability analysis. I think reachability analysis is where my money is at and where we're investing tons of. And eBPF is one of the elements that we looked at, but the advantage was like really marginal, like probably 5 or 10% more precisions, regardless in respect of the other technique that we use, that is traceability analysis from code to cloud, and looking at profiling which container come from where, how they're sandwiched out, and how they're stacked up. So eBPF is one of the element of the cake. My hot take on that is maybe application security should stop talking application security and should start talking the language of threat and threat intelligence more, to bring back in front of the table the language that security has been using for forever. We've been isolating ourselves with this crazy complicated engineering concept and alienating a little bit the generation of CISOs that are not practical with engineering practice. So my hot take is I'm gonna talk a little bit more about threat-centric view of application security and attack surface management.
We are full of hot takes today, I think, and a lot of different ones. I think then maybe as we wrap up this conversation here, maybe we could just do one final sort of pass through if anyone wants to share any final hot takes, key things they want to drive, or also exciting things you're working on at your respective companies or projects that you're involved with. Brian, you want to start? I'm looking at my Zoom, moving around the
Yeah, I think my name starts with a B, so I'm probably first. I'm most excited about, I think, just about efficient engineering. I think one of the things that's actually our core strength at Impart is that we just have a lot of operational experience from previous companies. For example, for me, I've worked on 4 different WAFs in my career, right? So the one we have at Impart is the 4th one that I built. And so I have a lot of scar tissue around how to do that well. What are the problems people are facing? How can you do that efficiently? And so a lot of those learnings are what we built into Impart, and we solved that problem super well. Same with API security. And I think what I'm most excited about is how we can, like, we have all of those lessons built in. And so now having an additional data source of eBPF, like we already know how to do things efficiently and scale and process data and transport it across distributed systems and so forth. That's the hard part. I think just adding additional data sources we have an eBPF agent, for example. It's actually not been the hardest part about building a compelling solution. And so I'm excited that all of the lessons learned are going to continue to bear fruit in the future for us.
So
How about you, Daniel?
Yeah, I criticized a lot, I think, during today's talk eBPF, even though I still gonna invest, but also agree with Francesco and everyone that yeah, we have to be a little bit skeptical from the engineering standpoint. One company using eBPF successfully for software-defined network, again without names, doesn't mean that you will be successful with eBPF, right? They just used brilliant engineering. They use it. Maybe the engineering team is composed of kernel maintainers. They know how to use it, how to use this technology. As I was saying, for me, I would love to see more mature or easier development environment. I'm always looking from the product day to operations. We deploy and then what? eBPF can crash just because a new kernel version is released that is fixing a bug in eBPF verifier. So we haven't touched our code, but it stopped working. There was an infamous incident with agents on Windows recently. So again, back to reality. I know some vendors will hate me, but some engineers will appreciate it, hopefully. Those are real concerns, right? eBPF is secure because the sandbox is secured, but it doesn't mean that it's, like with a car, right? Cars are not secure. The driver is really the person that makes them secure. So that's the analogy. And my advice would be to, yes, stay on top of what's going on in the ecosystem and jump on and help. This is an open source project. Everyone can contribute by complaining, by sending code, or by just improving the documentation. I think the documentation is another big pain point of eBPF, right? It's scattered everywhere. So, yeah.
I'm going to
Just don't
take
use
that,
AI like
contribute by
her.
complaining.
Yeah, I like that, Don.
Francesco,
Last take on
bring us
me,
home.
I think reachability analysis where my heart is at, and in the 4 different reachability analysis that we implement, from attack path to code to cloud reachability analysis, because we use reachability analysis as a visibility tool. We start discovering stuff with reachability analysis that I haven't thought about it, and it was a pleasant surprise. So we can automatically detect which particular piece of code come from which particular container, that helps us tracing which application is being built by whom, and hence who you can attribute the particular vulnerability in a container, inferring information. And this doesn't use eBPF at all, because we tried it and it didn't solve the problem. We way more excited about this because really help burning down vulnerability. We actually managed to reduce in one particular client 91% of container vulnerability with switching them off, because they were actually addressable in code, not in the container noisy part. So that's the stuff that really get me excited, because being from the opposite side, having to deal with those vulnerabilities, it's not a fun job.
Yeah. I really like what Francesco said about a domain language of Appsec. So I would say and advise to jump on Appsec dictionary or a glossary, and then jump on eBPF program types, eBPF maps, and all that madness. Because if you do the reverse order, you end up with a product that generates data, but it's not meaningful. So I really love this approach where we focus on the problem and then we choose the technology. eBPF might be a solution for your product, but maybe you don't really need it. And that will save you a lot of problems.
I think I turn it back to you, Katie. Do you have any kind of parting thoughts for us?
No, I guess in my crystal ball and key takeaways from all of this is that I think we actually did in this conversation today a really good job of de-hyping eBPF in a lot of ways. And I think that's much needed. And I very much see that this technology comes up across the Appsec spectrum and all when I engage with vendors from, like I said, from WAF to API security to ASPM to application detection and response, and even in supply chain security use cases. And so I think it's super important to be like real about any tech and what what's its best use cases and what it can deliver, but also be real about what are its drawbacks and its concerns, and not get on these hype trains. And us analysts are part of this, of where we talk about a technology or even an acronym and we lose the deeper meaning of what it is. And so I think this conversation, and I'm so glad we had it today, I'm hoping all of our listeners take away with them some not only better understanding, but a reality of what eBPF is and some good hot takes.
Cool.
Awesome. All right. Thank you to everybody who's listened in, and thanks everyone, Brian, Daniel, Francesco, for all of your thoughts. This has been an awesome conversation.
Thank you, everyone. Stay safe out there.
Thanks, everybody.
Bye.